4 LSA1 will be there in area 0 or 5. 4 or 5 guys.
5.
5 in area 10.
4.
4. And in area 10, how many LSA3 will be there?
2.
No.
5.
Okay, in area 0, how many LSA3 will be there?
4.
No. Okay, in area 10, how many LSA 5 will be there? LSA 5.
I think in area 0 we have two summary.
Only 2.
40.11.
Router 4 and router 5 will share these all prefixes in area 0 with the help of which LSA? LSA 3. Even
3.
network on this link, network on this link, and network on this link. So 3 network are there, 4, 5, 6. 6 LSA3, router 4 will send 6 number of LSA3 and router 5 will also send 6 number of LSA3. Right. So here total number of LSA3 is 6 plus 6, 12. And how many LSA3 router 3 will generate? Prefix which is running on this segment, prefix which is when we will configure virtual link here. For now, let's say virtual link is not configured, then router 3 will generate one number of LSA3. So total number of LSA3 in area 0 is 13. Am I right?
And router 2 also will generate. Oh, okay, that is AIJP,
LSA2
right?
is
Okay.
ASBR. It will generate LSA5.
Okay. Okay.
How many
Sir,
LSA5?
recording is on.
Yes, recording is on. How many LSA5? 1, 2, 3, 4, 5. 5 prefixes here. 6, 7. So it will generate
Means
7.
only it will send only that summary only, right? That is like 60.1.1, something
No,
like that. Or
no, it will send all individual prefixes, not summary address. We can summarize it, but by default it will share all these individual prefixes with /24.
okay. Okay, I thought like 70.1.1 and 60 like that. Okay. Okay.
Okay. And router 8 will generate 1, 2, 3, 4, 5, and 6. 6 number of LSA5 in this domain. So again router 4 and router 5. Both router will forward LSA 5 of router 8 in area 0. Both router will forward LSA 5 of router 8 in area 0. And here router 2 is sharing LSA 5 in area 0. So you can calculate it. First of all, what I will do in this scenario, let me show you R1 routing table or database. Let me check R1 external prefixes. So IP ospf, so IP route so IP route ospf, so IP route ospf external. So we don't have any, so IP route ospf, sorry. So here we don't have any prefixes from ospf domain. Why? On router number 1, so IP route ospf, we don't have any prefixes. So IP route ospf external. Okay, here we cannot use. Why we don't have any route here in the routing table of ospf? Like router 1 have these prefixes. Let me check database of R1. So IP ospf database. Inside the database we have some LSA1 first of all, LSA1 of router 1, LSA1 of router 2, LSA1 of router 3, 4, and 5. All routers in this domain are generating LSA1. That is fine. Router 3 and router 4 are generating LSA 3. We don't have any LSA 2 here. 3 router 3 and router 4 are generating LSA 3 and it is sharing inter-year prefixes like 39, 40, 40.1.1.1, 40.1.1.1. Both router and router 5 is also advertising. Where is R5? Yes, R4 and R5. R4 and R5 both are advertising same prefix like 40.1.1.1. Where is 40.1.1.1? Here. On R5 and on R4 we have loopback like 70 prefixes. If you will see 70 prefixes on router number 7 we have some loopback. You can see 70.1.1.0, 70.1.1.0. router 4 is also advertising and router 5 is also advertising. What router 1 will do? Which one router 1 will install in their routing table? Router will calculate what cost. Am I right? So IP route, why we don't have any prefix? So IP route ospf. So IP ospf interface fast Ethernet 2/0. Network type is point to point. That is very good. On R4, just give me 1 second. So IP ospf interface fast Ethernet 0/0 include here network type is point to point. That is absolutely right. On fast Ethernet 1/0 network type is point to point. And let me check finally on R7. So IP ospf interface fast Ethernet 0/0 include network type. Here network type is point to point. Everything is fine here. So IP route ospf, here we have these prefixes like 10 prefixes which router 1 is advertising, and you can see router 7 have learn install these 10 prefixes from both ABR router, from router number 4 also, from router number 5 also. It is performing load balancing. It is performing what? Load balancing. It is performing load balancing here. And why R1 is not receiving then installing prefixes in their routing table? So IP route ospf, here I think clear IP ospf process. Let me say yes. Let me clear ospf process once. And so IP route ospf, so IP ospf database. So we have prefixes in database. External LSAs are not there, means I think we have not performed redistribution on ESBR routers till now. That's why R1 is not receiving any LSA 5, but R4 R1 is receiving one LSA 4 from which router? This is summary ESBR LSA from router number 4 and from router number 5. Actually router 4 and router 5 are converting here LSA 5. Here router advertiser router ID should be what? 8.8.8.8 means router 8 is advertising external prefixes in this domain. So these are both router are acting as a ESBR also for now. We will discuss this concept also. Why? Because router 4 and router 5 is ABR router, but it is acting as, okay, it is generating, this is LSA 4, correct. ABR router is generating LSA 4 to share ESBR information about router 8. This is correct. I was thinking that is this LSA 3. Fine. Right. And then we have LSA 3 here. But why router 1 is not installing it in their routing table then? This is question. it should install these all prefixes in routing table. So IP route ospf, it have not installed. Let me do one thing. Let me stop this router and let me turn it on again. I think there is some problem. Router 4 and router 5, both router are generating LSA 4 to share ASBR information in area 0. And is there any more ABR router? Yes, router 3 is ABR router, but router 3 is not receiving any prefixes from ESBR. LSA1 from ESBR. Okay, in LSA1 ESBR router will on which bit, guys? ESBR router will on which bit in their LSA1? So run section ospf. Okay, distribute list is configured here, right? Actually I have configured filtering here, that's why it's not working. Distribute list number 10, so access list number 10. So you can see I have one access control list and I have called this access control list in distribute list. So let me say no access list number 10 and then router ospf process 1, and here I am going to remove this command, say no to this. And now so IP route ospf, yes, now you can see router 1 have these all prefixes, all 70 prefixes in the form of which LSA. If here symbol is OIA, this is inter area prefixes, right? That means router have learned it in the form of LSA
3.
3, right? And router have not learned any prefixes in the form of LSA 5. That's why we don't have any prefixes with EX, correct? And here also we don't have any prefix with O symbol. So router 1 have not learned any prefix in their on domain in area 0. So you can see in area 0 we don't have any prefixes. We have all are directly connected with router number 1, like prefixes on link. So this is, hope this is clear to you. So IPOSPF database of router 1 should be very clear to you. Inside the database of router 1 we have lots of LSA 3 and router 3, router 4 and router 5. These three routers are generating LSA 3 because these three routers are ABR router, fine. And router 4 and router 5 are sharing these 70 prefixes to router number 1, and router 3 is sending prefixes running between router 3 and router 9, because here we don't have any loopback also. So save the configuration and so IPOSPF database, and inside the database we have two number of LSA 4 also. Router 4 and router 5, again ABR router are generating this LSA. To share which route link ID in the LSA 4 is router ID of ASBR. Link ID in LSA 4 is router ID of ASBR. Got it? Got it, guys?
Yes.
And here on router we have one more command to check how many number of LSAs are there. We can use this command, so IPOSPF database and database summary. With the help of this command you can see on router number 1 how many router LSA are there. 5. How many network LSA are there? 0. How many summary LSAs are there? 15. In which area? In area 0. And how many LSA 4 are there? How many LSA 7 are there? Okay, and total number of LSAs on this router. After that, in ospf process 1, okay, so router LSA is 5, summary LSA is 15, summary SVR LSA is 2, right? We don't have any external LSA or a type 7 LSA. So this is total number of LSA, and self, non-self means node generated by this router, means received LSA is 21 and total number of LSA is 22. That means this router have generated how many LSA? Only one number of LSA, that is
LSA 0.
LSA 1 na yaar,
1
router LSA. See, 1.1.1 is generating only this LSA. After that, router 1 is not generating any LSA here. Why router 1 will generate any other LSA, right? It is not ABR router, it is not ASBR router, and here DR and BDR election is not happening. So now on router number, first of all, here I should configure virtual link, then we will discuss anything else. Because R1 is not receiving, see, R1 is not receiving any external prefixes, so IP ospf database, it is not receiving any external prefixes, and it is not receiving these prefixes, right? Prefixes which is running on router number 11, like 110.1.1.0. Why router 1 is not receiving this prefix? Because router 11 will share these all network information in the form of which LSA? LSA 1. And can LSA 1 cross area? No. And can router 9 generate LSA 3 to share this area prefixes in this area? No, because router 9 is not
ABR.
ABR router, right? So here between router 3 and router number 9, I can configure one virtual link just to extend area 0 from router number 3 to router number 9. Simply we need to run two commands, see, one on router number 3 and one on router number 9. Let me see, check router 3 console. No, let me access R3 here. On router number 3, I will run this command, router ospf process 1 and then area 1 virtual link and then router ID of neighbor router 9, 9.9.9.9. Okay, and then let me access router 9 here, and on router number 9 also we will run this command, same command, router ospf process 1 area 1 virtual link and router ID of router 3 3.3.3.3. Now just wait for some time. After some time you will see. Now what will happen here? Both router will start sending unicast hello message, and you can see now we have one ospf neighborship on virtual link. Now we have one ospf neighborship on virtual link. Here we can run this command, so IP ospf interface brief. You can see ospf is running on this virtual link also, and in which area it is? It is in area 0, right? So IP ospf neighbor. So ospf router 9 have now how many neighbors? 3. One is router number 11, right? One is router 3 on virtual link, and one is router 3 on fast ethernet 0/0 link. 1 minute guys. Fine. So virtually now router 9 is connected with area 0. So now here we have some verification command
but
also.
here in that, hello, in
Yeah, yeah.
that router 9 neighbor, na, in that router 9 neighborship command, in the table, it's
Hmm.
showing only that 5.1. Why?
This is IP address of router
4.1.
11. This is
Oh,
router
sorry.
ID
Okay,
of
it's a
router
high.
11, you can say.
Okay, okay, okay. Highest number. Okay.
Okay. Here on router number 1 maybe I have not configured router ID there. So what we can do on router number 11, let's say first let me configure it. Enable config t router ospf 1 do so IP protocol summary. We are running ospf process 1, so router ospf process 1 router ID 11.11.11.11 do clear IP ospf process, do clear IP ospf process, clear IP ospf process. So IP protocol. Now router ID is 11.11.11 and now on router number 9 you can check routing table again, sorry, neighbor table again. Okay, now it's fine.
Yes, yes.
Okay, and on router number 3 also we can see, so IP ospf neighbor, so one neighbor on virtual link, that is 9.9.9.9, and on router number 3 so IP ospf, so IP ospf virtual link, this is also one command. We can check virtual link configuration. Virtual link, this is name of virtual link to router whose router ID is 9.9.9, state is up. Virtual link in ospf work as a demand on circuit. This is one a small concept, guys, sometime we will discuss this. Okay, what is demand on circuit? Generally we are using it in ISP side. So ospf virtual link works on demand or on circuit, and now it both router have exchanged their hello message on unicast address. Both router have exchanged their hello message on unicast address, and here hello time is again 14 second, date time is 14 second, and wait time is 14 second. Time is same, and state is point to point. So these are information about virtual link. Now so IP ospf database, inside the database you can see router 3 is receiving some summary LSA, and in the form of summary LSA it is receiving all these prefixes, 110 prefixes, which is running on router number 11. Who is advertising it? Router 9. And here we have one DND. Do not send, see here, do not age. Do not age means what? See, for these LSA on router number 9 we have many LSA, but for these LSA router is not running any age time. Router is not running any age time. For these LSA router is running one actually age time for 30 second. After 30 second it is expecting LSA from their neighbor. But for all the prefixes which router will receive through virtual through the neighbor on virtual link, it will set do not age bit. So timer is not working for these prefixes. This prefix will be permanently in the database of router 3 and in the routing table. Okay, and so IP route ospf, here you can see it have installed these all prefixes in their routing table also. Advertiser is router number 3, router number 9, correct? Now router number 3 and router number 9 is ABR. So on router number 3 if I will run this command, so IP ospf border router, so now we have one new type of ABR, that is router 9, that is router 9, and this is neighbor ABR on virtual link, ABR on virtual link. Fine. So you can imagine that we have one link now between router 3 and router 9, and we have advertised that virtual link in area. In which area?
Area 1.
Area 1 or area 0? Area 0.
Area 0.
Area 0.
And whenever router 1, router 3 and router number 9 will send their LSA1 on virtual link, it will on which bit? B bit. As I told you, then LSA1 there are 3 bit. One is B bit, one is E bit, and one is V bit. So V bit is for virtual link, E bit is for ASBR, and B bit is for ABR. Correct? If I am not wrong.
Can you repeat it again?
V bit is for virtual link, E bit is for ASBR, and B bit is for ABR. Whenever ABR router will generate their LSA1, it will on always this bit. It will on this bit, B bit. Generally, all router in ospf domain generate their LSA1 with these all bits off. These 3 types of special router will on this bit, like ABR will on B bit. So whenever a router will receive LSA1 with B bit on, router will understand that okay, this router is ABR router. If router will receive LSA1 with E bit on, router will come to know that this is ASBR router. And when router will receive LSA1 on virtual link, it will find V bit on LSA1. Okay guys, is it clear? Clear?
Yes.
Question? Any question? No?
Can you show it in Wireshark? That
Yeah,
B bit on.
I can yes capture this link. Let me capture the link here. And simply on router number 3, I can run this command clear IP ospf process. When router 3 will send update message to router number 9, source will be 39.1.1.9. So let me open LSA which router 3 is generating. Source is 13.1.1 R3. Let me check IP. So IP interface brief exclude and assign. Here we have 39.1.1.3 IP address.
You try to open the fast Ethernet 1/0.
I have captured this link now, fast ethernet 0/0 I think. Okay, in this LSA, this is LSA on this link, like on fast ethernet 0/0 link. In this LSA, which bit will be on? When router 3 is sending their LSA1 to router number 1, it will on which bit?
B.
B bit.
V bit. So inside the LSA1, V bit is on here. And let me do one thing here. I have captured wrong link. fast Ethernet 1/0. Which router is sending this LSA? Router 3 to router number 9. These are which LSA? LSA 3. But we are looking for LSA 1. Here is the LSA 1. Inside the LSA 1, we are going to check flag field. In flag field, it have set this bit on only. ABR router B bit. B bit is still, this is not correct LSA. Which as LSA it is? It is LSA 4. You have to check which message is, router 3 is sending on virtual link. Here you can see VBT is on. Router 3 is sending this LSA 1 on multicast address. And here VBT is on. It is sending this LSA 1 to their virtual link neighbor. It have found one neighbor on virtual link also. So it is sending to that neighbor this LSA 1. So that's why it have set virtual link bit on. And this router is AVR also, so it have set this bit also on. 2 bit is on in this LSA. So when router number 9 will receive this LSA, router 9 can came to know that router 3 is AVR, as well as here we are running virtual link. Okay. Now on router number 1, I am expecting all these prefixes, 110 prefixes here in the routing table. So IP route ospf 110, yes. Router 1 is also receiving these all prefixes. Next up IP address is 13.1.1.3, and so IP ospf database. Inside the database also you can see router is receiving these prefixes in the form of LSA 3. LSA 3, and which router is advertising this LSA 3? Router number 9, right? And DND bit is on with these all prefixes. Fine. LSA 3 can cross area, na? Right? Router 9 is generating LSA 3 because now the router 9 is AVR router. So it will generate LSA 3 to share these all prefixes in area 1. Right? And LSA 3 can cross area, so that's why router 1 have received these prefixes where advertiser router ID is 9.9.9.9. Now I am interested to talk about these prefixes. So IP ospf database. Inside the database we have some summary LSA for 70 prefixes, for 70.1.1.0 to 70.1.3.0. You can see where we are running these prefixes on router number 7.
7.
And router 4 and router 5, both router are advertising this LSA 3, and router 1 is performing load balancing for it. So IP route ospf 70.1.1.0 255.255.255.0. This prefix is not in table. So IP route ospf 70.1.1.1/32. What is happening? right? We have how many next hop in the routing table? 2. One 15.1.1.5 and one is 14.1.1.4, means router 4 and router 5. Hope till here everything is clear to you. Now on router number, on ABR router 1, let's say this is my ABR 1, this is my ABR 2. I don't want to advertise these all individual prefixes in area 0 via ABR 1 router. Via AVR 1 router, I want to advertise, let's say, one summary route of these prefixes. So simply here I have one command on router number 4 that we can run is config t. This is how we can manipulate ABR router when we have multiple ABRs. Router ospf process 1, and then here we can run this command area 0 70.1.0.0, let's say 255.255.255. Sorry, 0.0, area 0, and here I think range. Yes, this command. So now this AVR will advertise this summary route. Now you can see on router number 1, where is R1? Here it is. In the R1, first of all, show IP ospf database. Inside the database, 470 prefixes. Again, still router 4 is also advertising, router 5 is also advertising all individual prefixes. Now we don't have any change here. Oh, this was area 10. This was area, this is prefix of area 10, not area 1. So let me correct it. Here first I am going to say no to this, and then area, I said area 0. So area will be here 10. Area should be 0 or area should be 10. So prefix belongs to which area? Area 10. Area 10, range 70.1.0.0 255.255.0.0. Right. Now let me check R1 routing table. Now you can see in the routing table for this prefix we have only one path via which router? Via router number 4. Now see the database. So IP ospf database. Inside the database, 470 prefixes, router 4 is advertising only this prefix 70.1.0.0, and 70.1.1.0 via is received by router number 5, 2.0 via router 5, 3.0 via router 5. So now router will forward all traffic in this network via router number 4, via router number, sorry, 5, not 4, because now router 4 is advertising one summary route. So IP route ospf, inside the ospf routing table also we can see for 70 prefixes, you can see it is receiving one summary route from router number 4, and it is receiving all individual prefixes from which router? From router number
5.
5. Right. So this is also one command, right, to advertise summary route when we have more than one ABR in ospf domain. Fine. And we can filter prefixes also, like let's say these 70 prefixes. I don't want that router 5 should advertise these 70 prefixes in area 0. So on router number 5 we can filter it. We can instruct to router number 5 that please don't generate any LSA to share these 70 prefixes. How? On router number 7, first of all I have to match the traffic, I have to classify the traffic. So we can use access control list or prefix list. Any method you can use. Let me use prefix list. IP prefix list, the name of prefix list, let's say ABC, then deny which network? 70.1.0.0, let's say 1.0/23 less than 24, right? All prefixes will match in this or not? All prefixes will match in this or not? Yes. And then IP prefix list permit 0.0.0 permit IP prefix list ABC permit 0.0.0.0/0 less than 32. And now I can call this in ospf router ospf ospf process 1, and here we can say area 10 area 10, or here area should be yes, area is 10, this prefix is present in area 10. Then command is filter list then I will call to prefix list, name was ABC, and in which direction you want to apply it. I want to apply it in odd direction, that you should not advertise in area 0. And now again, if you will check router 1 database, so IP ospf database, inside the database we have still these prefixes from router number 5.
That should be
Okay.
/22.
Yeah.
Gave 20.
Yeah, exactly. So we have, this is how we can filter LSA 3 also. So I have filtered 70.1.1.0. Router 1 is receiving one summary route from router number 4 and is receiving these two prefixes from router number 5. It have filtered 70.1.1.0. Got it? So just these are two small command that you can use on ABR router to filter. Now we will discuss about redistribution. Okay, so this is database of router 1. Inside the database I have filtered some prefixes. First of all, let me remove that command. On router number 5 I'm going to say, where is router 5? Here it is. On router number 5 I am going to say no to this, and no IP prefix list ABC. Fine. On router number 4 I am going to remove this command. That's it. Now router 1 is receiving 70 prefixes from both ABR router, so IP ospf database. Inside the database you can see for these prefixes we are receiving LSA 3 from both ABR router 4 and router 5 both are advertising these prefixes in the form of LSA 3. But now here we don't have any external LSA, so IP ospf database we don't have any external prefixes. That means we have not performed redistribution here, right? So let me perform redistribution. First of all, I am going to perform redistribution on router number 8, because router 8 is connected with EIGRP also and OSPF also. So where is router 8? Here it is. In router 8, first of all, let me check it is receiving 100 prefixes from EIGRP or not. So IP route EIGRP. So yes, we have some prefixes in EIGRP domain. You can see router 8 is receiving these all prefixes from EIGRP. Fine. And so IP route OSPF, it is receiving these prefixes from OSPF, like 70 prefix, 110 prefix, 110 prefixes, and prefixes of area 0. Router 1 is advertising these 10 prefixes. Okay. Now on router number 1, I will redistribute EIGRP prefixes into OSPF. So see guys, router OSPF 1 and redistribute EIGRP as number 200 and subnet. This is the basic redistribution command, right? If I will hit enter here, see one thing. Let's say here I have one router. I have one router here, one router here, and one router here. R1, R2, R3, and let's say this is R4. This is my ospf domain, right? And this is my, let's say, EIGRP domain. Here this is my EIGRP domain. This is EIGRP, let's say 10, and this is ospf 1. Fine. So these two router 2 and router 3 are ESBR router, right? Let's say router 4 have one network 40.1.1.0/24, right? So both ESBR router, this is also ESBR, and router 3 is also ESBR. So in this scenario, both router 2 and router 3 will advertise 40 prefixes in ospf domain in the form of which LSA? In the form of LSA 5. 3 or 5? ESBR will advertise in the form of LSA 5, brother. 5, right? LSA 5. It will also advertise it by LSA 5. Correct? Now, when we are running this command, router ospf1 and then redistribute EIGRP as number 10 subnet. It will redistribute EIGRP prefixes in ospf with type 2 metric. In type 2 metric, all router in ospf domain will not use their cost to calculate metric. Let's say cost of this link is 5. So when router 2 will advertise 40 prefixes with type 2 metric, router 1 will install 40 prefixes with same metric which router 2 is advertising. Let's say router 2 is advertising 40 prefixes with metric 20. So it will install this prefix 40 prefix with metric 20. It will not add their on metric, like router 1 is connected with another router, that router will also calculate same metric, that will be 20. Okay, means router is not going to use their on interface cost, right? It will install prefixes in their database, in their routing table with the cost which ESBR router is advertising. Okay, cost which ASBR is advertising, means in OSPF area 1 domain, if we have 20 routers, so on all routers for 40 prefixes cost will be same, because those router are not going to use their own interface bandwidth. So in my scenario, let's say in this scenario, if I will advertise these prefixes here on router number 8, I will perform redistribution of EIGRP into OSPF. Router 8 will advertise these all prefixes with metric 20. Router 7 will install these all prefixes with metric 20. Router 4 will install these all prefixes with metric 20. And router 1 will also install these prefixes with metric 20. Let's say metric on this link, cost on this link is list, here cost is 5 and here cost is 20. So according to OSPF, which path is best? Upper path is the best path because we have list cost. But for all external prefixes, router 1 will get same cost from both sides. For external prefixes, router 1 will get same cost. Let's say for here I have changed the cost to manipulate the ABR router. I don't want to forward any traffic from OSPF 0 to OSPF area 10 via router number 5. So here I have increased cost, let's say 10, and here my cost is 5. But still for external prefixes on both link, router 1 will calculate same cost, that is 20. This is behavior of type 2 metric. Type 2 metric, and that is by default. But while redistribution, we can change metric type also. If we will set type 1 metric, we have two types of metric while redistribution. Type 1, if I will set type 1, then all router will calculate their receiving interface. It will add their receiving interface cost in update message with the prefixes. Like when router 8 will advertise these prefixes in OSPF domain, router 7 will add their own interface cost, then it will advertise to router number 4 and router 5. Router 4, router 5 will add their own interface cost, then it will advertise to router number 1. Router 1 will add their own cost, own interface cost on both link, then it will compare which one is best, and this time best is via router number 4, not via router number 5. Okay, and in OSPF, when we will redistribute external prefixes in OSPF with metric type 2, then router will install that prefix with symbol E2. When we will redistribute OSPF prefix external prefixes in OSPF domain with metric type 1, then OSPF router will install in the routing table with symbol E1. And if I will talk about best path selection in OSPF, best path selection of router, as you know, first it will check longest prefix match, then it will check AD value, then it will check metric, right? But the best path selection of OSPF is, let's say here I have one topology like this. I have one topology like this. Here I have R3. Router 3 is connected with two router, R1 and R2. Fine. And both router is advertising one network, that is, let's say 10.1.1.0/24, and this router is also advertising 10.1.1.0/24. Now how router 3 will identify which one is best? For that, first of all, definitely it will check AD value. So both side we are running OSPF, so AD value will be 110, right? Then it will check metric, metric. But here in OSPF it will not check metric. First OSPF will check route type. After AD value, OSPF will check route type, right? And we have multiple route type in OSPF, like prefix with O symbol, prefix with O symbol, prefix with OIA symbol means inter area prefixes, prefix with E1 symbol means redistributed prefix with metric type 1, then E2 prefix with metric type 2, then NSA area 1, NSA area 2. We have these all symbols in OSPF. These are route type, and always keep in mind O is more preferable than OIA, and OI is more preferable than E1. E1 is more preferable than E2. E2 is more preferable than N1, and N1 is more preferable than N2. Getting my point? So in this scenario, if let's say simply my simple requirement is I want to receive 40 prefixes, I want to install 40 prefixes on router number 1 via router number 2. So here I will redistribute with metric type what? 1, and here I will redistribute with metric type what? 2. Even cost is same on router number 1 from both side, right? But first it will check what? Metric type. So metric type 1 is preferable on metric type 2. It will install this prefix via router number 2. Got it? Is it clear? So here in my scenario on router number 8, I am going to perform first C redistribution. So command is, first command is this one, basic command router ospf 1, and then redistribute agrp s number 200 and subnet. Now if I will advertise it like, if I will redistribute it like this on R1, you can see on R1 or on R7 also, on R1 show IP ospf database. Inside the database now we have some external prefixes. We are getting these all prefixes in the form of LSA5. We are getting these all prefixes in the form of LSA5, and advertiser router is router number 8. And if I will show you routing table, so IP route ospf, you can see all 100 prefixes. Here symbol is OE2, means these are redistributed prefixes with metric type 2, but here while redistribution on router number 8, I can say what, and see, because metric type is 2, this is also important, metric type is 2 because of metric is 20, and on router number 1 also, this is router 1, on router number any other router also, like on router number 7 or 4, router number 4, on router number 4 also, so IP route ospf for 100 prefixes, you can see cost is 20. This is cost which ASBR is advertising, means router 1 is, or any router in ospf domain is not using their interfaces cost, because here on router number 1 you can open this prefix in detail also to check cost. So IP ospf database, then external, and we always open external LSA with link ID, any LSA with link ID. So here link ID in external LSA is, you can see 100.1.1.0. So IP ospf database external and 100.1.1.0, 100.1.1.0, 100, right? Here you can see metric type is 2 and metric is 20. Who is advertising this LSA? Router number 8, 8.8.8.8, advertiser router ID 8.8.8, with what cost? 20. And this router have installed this network in their routing table also with same cost, 100.1.1.0, 255.255.255.0, cost is 20. Okay, but if I will change metric type on router number 8, let me take you to R8 again, and this time here I am going to say metric type 1. I have changed the metric type, and now on router number 1, metric is now what? 23. Metric is 23, but metric which is coming in update is 20, right? Metric which is coming in update is 20, and cost to reach 8.8.8. so IP ospf border router, cost to reach 8.8.8 is 3. So total cost is 23. That means this time router is using their on receiving interface cost also with the cost which is coming in update. Fine. So we have two options to redistribute. We can redistribute prefixes with metric type 1 or we can redistribute prefixes with metric type 2. And now if you will check routing table, so IP route ospf, you can see symbol is also changed, OE1, and OE1 is more preferable than OE2, means it is ospf external with type 1 metric, ospf external with type 1 metric. So in type 2 ospf cost is not added, in type 1 ospf cost is added at every hop, at every hop cost is added. And by default, when we are redistributing any other domain prefixes in ospf, it is redistributing with cost what, with cost, sorry, with metric type E2. Okay, so IP route 100.1.1.0. Okay, this is external prefix type, external. Okay, then okay, we will discuss about these things also. Now we can use route map here, we can use tag, we can say NSS area. So till here, any question? Okay, see, from these all prefixes, I want to advertise only upper 3 prefix, I don't want to advertise lower 2 prefixes. So how I can achieve it? What will be the summary address of upper 3 address? 100.1.0.0.
Yeah, 0.0/22.
/22. And summary address of lower 2 network?
4.0/23.
Okay. On router number 8, this time I am going to say no to this command first, no to this. And now IP prefix list, let's say name is ABC, permit 10.1.0.0, subnet mask will be 255.255,
252.
or we can say slash na,
0.0.
here /22 less than 24. Now what I can do here, I can create one route map ABC. In this route map I can say match IP address prefix list name ABC, and while redistribution I can call this route map. While redistribution I can call this router ospf process 1 and redistribute EAGRP as number 200 subnet and metric type subnet route map ABC, and then we can say metric type also, or first you can apply metric type, then you can apply route map. Let's say metric type 1. So now it will redistribute only those prefixes which will match in route map ABC. And in route map ABC we have defined what, match IP address from prefix list ABC, and in prefix list ABC we have defined this network only, right? So on router number 1 or any other router in this domain, we can check routing table. So IP route ospf 400 prefixes it is receiving, but all prefix. On router number 8, redistribute EAGRP20 subnet route map ABC metric type 1. Everything is correct. Where is misconfiguration? So route map, then no match. So IP ospf database. Inside their database, I'm going to check external LSA. Router number 8. Redistribute EAGRP 200 type 1. Correct. So IP ospf database. Oh, these are 110. These are 110. Now routers are not receiving any external prefixes. Routers are not receiving any external prefixes because see here on router number 8 we are not able to see any LSA 5. So what is happening? Router ospf 1.
Can you check the prefix list? What we configured here?
IP prefix list ABC.
Do we need to permit all? Oh, this is permit. Okay.
Permit na.
100 or 10?
Oh, sorry. This should be 100 na. Let me correct it. No IP prefix list ABC. IP prefix list ABC permit 100.1.1.100.1.0.0/22. So IP ospf database. Now we have external prefixes, but we have these all prefixes. So IP ospf database. No, router 1 have not received any external LSA till now. It have also filtered. So run section ospf do so route map ABC permit a IP prefix list ABC do so IP prefix list. So prefix list ABC one entry is their sequence number 500.1.0.0/22. Router ospf 1 no redistribute EAGRP number 200 subnet. Redistribute EAGRP 200 subnet and route map ABC. and then metric type 1. So IP ospf database, nope. Still it is not receiving, it is not injecting LSA5. Let me do one thing, router ospf 1 and no redistribute. Let me say redistribute eigrp s number 200 subnet. So run section ospf. Redistribute eigrp. Oh, eigrp 200 metric type 1 subnet. So IP ospf database. Now it should install. Yes, now it is injecting LSA5, but okay, why command is not working for now? It's not working now. What command is same like this? You can filter external prefixes also. Okay, we can advertise only selected prefixes, or we can redistribute only selected prefixes also in ospf domain with the help of this command. Okay, now our next topic is ospf area. These are redistribution and about the LSAs, and we have only one LSA left, that is NSSA. So we will discuss that LSA also in area concept. Let me start the topic. Topic is type of areas in ospf. Type of area in ospf domain. So first type of area is, first of all, as I told you, all router belongs to a standard area, right? By default, standard area, all routers are in a standard area, and all areas are, you can say, a standard area. By default all areas are a standard area, and in a standard area all LSAs are allowed. In a standard area all LSAs are allowed. So to filter LSAs, we come up with ospf area concept. First type of area is stub area. Second one is totally stub area. Third one is NSSA area, and fourth one is totally NSSA area. So we have these four types of area in ospf. Okay, by default all areas are standard area. Okay, so we can configure manually, like here in this topology we can configure area 10 is stub area, or NSSA area, or totally stub area, or totally NSSA area. So first of all, see the meaning of these area. First one is stub area. So stub area is used to filter type 4 and type 5 LSAs. It is used to filter type 4 and type 5 LSAs. Means if I will configure what? LSA, stub area 10 is stub area. So in this area now LSA 4 and LSA 5 are not allowed. This area will not carry any LSA 4 and LSA 5. But here we have some foundation like, if I will talk about command, so command is very simple. Router ospf process 1, and then we can say area 10 stub. That's it. This command will configure area 10 as stub area. Okay. ABR router in stub area, what will happen? ABR router will generate default route in the form of LSA 3. Like here, router 2 is generating what? LSA 5 to share these prefixes in ospf domain. Fine. Router 1 will advertise these all prefixes to router number 4 and to router number 5 in the form of LSA 5. These all prefixes in the form of LSA 5. Router 4 will advertise it to router number 7, and router 5 will also advertise it to router number 7. So router 7 will learn these all prefixes in the form of LSA 5. But let's say in area 10 is my stub area. So now router 7 cannot install LSA 5, correct? Then how router 7 will communicate with this network? So for that, the ABR router, like router 4 and router 5, both router will generate one default route in stub area. So always keep in mind, in stub area, ABR router generates a default route in form of LSA 3, and as you know LSA 3 is allowed. Okay, but we can not make backbone area to stub area. We cannot configure backbone area to stub area. Means area 0 can't be stub area. You will understand this also, that why. Okay, but for now just keep in mind this, that we can not make area 0 or backbone area to stub area. Okay, or we can not configure stub area where virtual link exists, fine. So these are all about stub area. You can take one screenshot of it. This is command. Okay, 1 minute. Okay, any question? Can I move? Okay, so see, in this domain I am going to configure area 10 as stub area. Okay, so for now, before configuring it, let me redistribute external prefixes on router number 2 also. On router number 2, router ospf process 1 redistribute EIGRP as number 100 and say submit. That's it. On router number 7, you can see so IP ospf database. Router 7 have some external prefixes, some external LSS, and through external LSA it is learning all 60 prefixes. All 60 prefixes. Router 2 is advertising it in the form of LSA 5. Fine. Now on router number 7 I am going to configure area 10 is stub. Router ospf 1 area 1 area 10 stub. First of all, never see bill goes down. Why? Because stub flag will match, not match. Area should be matched to become neighbor. So IP ospf neighbor. So all neighbors are down. Fine. So let me configure stub area on router number 4 also. On router number 4 also I will run same command config t router ospf 1 area 10 stub. Now ospf neighborship will come up here. Till then let me configure r5 router ospf 1 area 10 stub. Correct. Now on router number 7 we can check so IP ospf neighborship again. Now you can see neighborship with 5.5.5 full, neighborship with 4.4.4 full, right? So IP ospf database. Inside the database we are not able to see any external LSA here, right? On router number 7 you can see we don't have any external LSA, but I am getting two default route in the form of LSA3 from my ABR router, from my ABR router, right? And what is main problem with this area, stub area? Guys, in stub area, see on router number 8, first of all let me configure router 8 also as stub. Router 8 should be a stub area, then only ospf neighborship will come up. Router ospf 1 area 10 stub. Fine. So IP ospf neighbor. Fine. So IP ospf database. Oh, where is the external LSA? Now see, router 8 have filtered all external LSA. That means OSPF domain will not get these prefixes now. Yes or no? That means we cannot configure area as stub area where ASBR router exists. Where ASBR router exists. Correct? We cannot configure stub area where ASBR router exists. Here R7 have no any problem because it have received one default route from ABR. So IP OSPF database, it is receiving one default route from both ABR, and it will advertise it to router number 8 also. Router number 8 have also, where is router 8? Yes. So IP OSPF database. Router 8 have also two default route. One of router 4 and one of router 5. But router 8 is not generating what? External LSA. So because this is ASBR, so ASBR should generate LSA 5. So we cannot configure a stub area where ASBR router exists. Hope it is clear. Fine. So we have second type of area, that is totally stub area. Now totally stub area is is used to filter LSA3. Let me write here. It is used to filter LSA3 because we have still lots of LSA on router numbers, LSA3 on router number 7. See, on router number 7 we have lots of LSA3s. So stub area cannot filter summary LSA. So if you want to filter summary LSA also, you can configure totally stub. So totally stub area will filter LSA3. It will filter LSA 4, LSA 4 and LSA 5. So totally stub area will filter LSA 1 also, LSA 2 also and LSA 5 also, right? So difference between stub and totally stub is stub area can filter these two LSA and totally stub can filter LSA 3 also. Otherwise both are same. Okay, again ASBR is not allowed in summary LSA. So let me configure here summary LSA. Sorry, totally stub area on router number 4. First of all, I am going to change it. Say no to this, and I am going to say area 10 stub area 10 stub no summary. Yes, this command. And router number 5 also router ospf 1. And first of all, let me remove this command. No to this, and then area 10 stub no summary. On router number 7 also router ospf 1 no to this command, and area 10 stub no summary. This is how we configure totally stub area, and on router number 8 also no area 10 stub and area 10 stub no summary. Fine. Now you can see we have ospf neighborship, and on router number 7 you can check the database. So IP ospf database. Now you can see the size of database because LSA3 is also filtered. Now only ABR router is generating what? Default route. That's it. ABR router is generating default route. So now
Sir,
size of database. Yes.
do we need to give in? Do we have to give in ABR only, right? No summary. Other routers we have to give a stub.
No, no. On all routers you have to give no summary.
Oh,
This is command to configure is totally stub area. See, on router number 7 also I have run this command. So run section ospf, this command, area 10 stub no summary.
can you remove and check in R7
What?
and R8 configure as area 10 stub? In
Okay,
ABR you configure no summary.
router ospf 1 no area 10 stub no summary, and area 10 stub. Yeah, this command is also working. So IP ospf database, both are same. Here we can on regular router you can configure area 10 stub also.
Okay.
Okay, so we have filter LSA3 also here. Now inside the database of router 7 or any router in area 10, you will not see any LSA3, any LSA4 and any LSA5. But problem over here is we cannot configure stub or totally stub if ESBR router exists here, because router 7 is not getting any default route from router number 8, or it is not getting these prefixes like 100 prefixes. So in ospf domain we don't have these 100 prefixes. Fine. So I am going to remove this configuration and let me discuss another area. Router ospf 1 no area 10 stub on router number 8 also. Router ospf 1 say no to this. Router 4 no to this, and router number 5 fine. Now let me show you database of router 7 again. So IP ospf database. Now it have, soon it will install all prefixes. Finally on router number 8. Okay, now we can see the database of router 7. So IP ospf database, right? All LSA3, and we have external LSA also for 60 prefixes and for 100 prefixes. Now we have next area, that is NSSA. So see, NSSA area is also used to filter. It is also used to filter LSA4 and LSA5. But here ESBR are allowed. Here ESBR router are allowed. Okay, so if we have ESBR router in my OSPF domain and I want to filter LSA4 and LSA5, I will configure NSSA area. And in NSSA area, guys, in NSSA area, ESBR router will generate LSA7. ESBR router, see, in this domain, let's say this is NSSA area. So in this area, LSA5 is not allowed. So what ESBR router will do? ESBR router will generate what? LSA7. LSA7 to share external prefixes in NSSA area. Okay, so that's why we have LSA7 here. Now let me show you. In this scenario, I am going to configure area 10 as NSSA area, and in NSSA area, ASBR router is allow. ASBR router will generate LSA7 to share external prefixes in ospf NSSA area. Command is same. On router number 4, I can run this command. Area 10 NSSA, that's it. Area 10 NSSA. On router number 5 also, area 10 NSSA, router number 7, area 10 NSSA, and on router number 8, area 10 NSSA. And now if you will check database of router 7, so IP ospf database, we have LSA3 but we don't have LSA5. Again we have LSA7. LSA7. And is ABR router generating any default route, guys? No. This time ABR router is not generating any default route. Then how router 7 will get 60 prefixes? This is problem. So this time I can tell to my ABR router to generate default route. Simply on R4, we can say R4 area 10 NSSA and default information originate. I can run this command. And now after running this command, if you will check database of router number 7 again, so IP ospf database, so this time you can see router 4 is generating one default route in the form of which LSA? Not LSA3, LSA7. Right, that means if router 4 is generating LSA7, so router 4 is my ESVR router. So in this scenario, yes, router 4 is acting as ESVR as well as ABR. So IP ospf border router, so IP ospf border router. In ospf border router also we are able to see 4.4.4 is ABR as well as ESBR. Okay, so when we will run this command on ABR router, ABR will start acting as ASBR and it will also generate LSA7. It will generate one default route in the form of LSA7. On R4 also I am going to run this command. Sorry, on R5 also I am going to run this command. Fine. Now both router will generate one default route here in this area. See now, router 5 is also starting acting as ASBR and ABR. So IP ospf database. Inside the database, we have now two default route. Both ABR router are generating LSA7 to share default route. Now can I ping 60 network? Ping 60.1.1.1. Yes, ping is working. Can I ping 100 prefix 100.1.1.1? Yes, ping is working. Right, but still database size is very large because of LSA3. So IP ospf database, we have lots of LSA3 here. So again, to filter LSA3, 4 and 5, we can use totally NSSA area. Totally NSA area will filter LSA4, sorry, LSA3, LSA4 and LSA5. Similar like totally stub area. This is similar like totally stub area. Fine. So here simply we can say on router number 4 area 10 NSSA no summary. Let me copy this command. Let me paste this command on router number 5 also. Right, and now on router number 7 we can see the database. Now you can see the size of database of router 7. Fine. So we have filter all LSA3. We are receiving a default route from ABR router. We are receiving default route in the form of LSA7 also from ABR router, and we have some LSA7, but we don't have LSA4, LSA3, and LSA. We don't have LSA3, LSA4, and LSA5. Done.
Which ABR will be preferred here for default route?
Router with highest router ID.
Okay, then R5 will be.
Yes.
Okay.
So this is LSA filtering with the help of area in ospf. Now what we have in ospf, we have some filtering concept and network type. So when we will meet after Diwali, then I will start ospf network type. That is also very interesting. Okay, this is all about today. Can I turn off it?
Jay, can you open that notepad, that areas, type of area?
Yes. आया